All right. So today I'm going to start by presenting just an overview of how to use the calculator. After that, Sammy is going to give us an example of how to put that into practice. And then after that, we're going to go into break rooms where you're going to then use the things that you've learned to apply them to a single assessment recommendation that we'll assign to you in a bit. So kind of just starting off, um, just getting started. The location of the file is already uploaded in Box. This is the way that you can get to it. So if you click on IIAC and then go to the reference files folders, and then go to the internal resources folders, and then the air quality folders, you'll see a thing called the user-friendly calculator. And I also have these slides already uploaded to IIC. A link at the bottom. There's a link that you can go to go to the calculator. One thing that we would like everybody to know is when you're using the calculator, if you could download it to your computer instead of working on it in Box, that will just help us to keep the air calculator clean for other people so that people don't have to like delete every single AR from another assessment and then populate it with their own. If we can just download that, make sure it's clean every time, it would be easier for everybody. So the information that you guys are going to need when you're using this calculator, it's pretty simple. No, I don't know what happened to my, anyways. So the three things you're gonna need in your calculator, well, to work the calculator rather, is the monthly electrical and gas savings, the location of the facility, and the natural gas burner type. Location of the facility should be pretty straightforward. You're already doing the monthly, well, you're doing the yearly electrical and gas saving. So there are a few ways that you can go about getting the monthly. For some ARs, you can just divide by 12 and that's enough. Others, you may only have winter or summer savings. So you'd have to divide it over the winter or summer months. But for the most part, it should be pretty straightforward. The one thing that you guys really need to work on finding out is the natural gas burner type. This information is usually not found on a nameplate. You usually have to talk to like an environmental engineer or the facility engineer. They probably know that information, but it's not readily available from the nameplate. And so kind of just going into the burner types, our first like separation is large, small. Well, so we have four different types of burners. We have large burners, we have small burners, we have T-fire, which stands for tangential fire, and then residential burners. So we have this big list. So you can see this is your first thing. Large is a burner that is 100 mega BTU or million BTU or per hour or higher, while small is less than that. And then a residential is even smaller than the small burner. It's only about 0.3 million BTU per hour. And then you also need to know about their control systems. Some controls have like no low NOx burner controls where they fire outside air to help like keep the air clean and make sure that the reactions when it burns go to completion. So that's what low NOx burners are. They also have something called flue gas recirculation, where they just take some of the flue gas that was burned off and recirculate it back into the burner to be used again, so we can get our reactions, our combustion reactions, to go to completion. So that you can see that here. This is in the calculator as well, multiple times. So you can look at it often, and then you can also talk to the air quality team, namely myself, Sammy, or Ellie, and we can also help you out with finding the correct burner type. So when you actually get into the calculator, you're gonna see the README before use tab, and that's just the instructions that I'm also gonna give here in this PowerPoint. It's got the instructions on how to do a single AR. It has instructions on how to do an entire assessment emission savings. And it's also got that list and description that I showed you on the last page. So I guess now we'll actually start into how to use the calculator now that I've kind of done the basics. So the first thing that you're going to want to do when you get into the calculator is you're going to want to go to the data insert sheet tab. So you'll go down and click on that data insert sheet tab. And from there, you'll see a bunch of different red, blue, and green boxes. So we have enough data insert tables in that sheet for 12 different assessment recommendations. And it's pretty simple on how to use it. You're first going to write the name of your assessment recommendation in the red box. After you write that name in, you're going to insert your monthly savings in the gas saving column or the electricity column. And then this is actually a list. The green box is actually a list. So it'll be a pop-up menu that you'll be able to scroll down and find the exact burner type that you want. So once you've gotten that data insert, once you've inserted your data into the calculator, you then have to decide which of the 3 tabs you're going to use to report your emission savings. And so I have 3 different tabs down here: the general, the WFC, and the UBZ. So the WFC is if you have a facility that is in the Wasatch Front non-attainment zone. So basically, if it's in this blue box, you are in the Wasatch Front non-attainment zone, and you will choose the WFC tab. And then you have the Uinta Basin ozone non-attainment zone, which is this green or turquoise box. And then anything outside of this is just use the general tab. So if you had a facility in Salt Lake City, you would choose the WFZ zone because it is in the Wasatch Front non-attainment zone. If you had something in Vernal, you'd be over here in the Uinta Basin. And then if you had something in, say, St. George, you would just use the general tab. So once you've identified the correct tab that you want to use, you'll click on it, and then you're going to have to find your table. So the name of the AR that you inserted in the red box will be found here. I've circled the AR name. It'll be populated, instead of that 1, it'll be populated with the name of your AR. And then you just have to choose one of the 3 tables. So if if your assessment recommendation has both gas savings and electricity savings, you're going to have to use this top table. But if you only have gas or electricity savings, you can use one of these 2 tables, which is smaller. So you've got the gas savings only table and then the electricity savings only table. And we've given that to you for your use. It just makes it easier on you if we give you those 3 tables to choose from. That way you don't have to delete columns in the gas and electricity savings. So once you've identified which table you want to use, You just copy and paste that table into your AR section, and that should be good. That's more for a Dominion assessment. We're going to be doing something a little bit different for an IIAC assessment. So for the IIAC, we're really going to be focusing on the total table, which you can see over here. It's also in every single tab. It's directly right of the first AR table, and it'll look like this. So you've got the total assessment emission savings. If you insert multiple ARs into your data insert sheet at the beginning, it's going to add all of them up together. So you have the entire emission savings of the process. So this is the table that we'll be using mostly for the appendix that we're going to be giving. So this is the one that for IIAC assessments, you're really going to want to focus on. Oh, I think, yeah. Oh, so Abby, location matters because Dr. Kelly will go into this a little bit more, but the location matters because we have things called non-attainment zones, and those non-attainment zones are areas where we have really bad air pollution, and we're really focusing on cleaning up those areas. So just showing that helps them understand just how much they're cleaning up the area. And Dr. Kelly, like Sammy said, will go into this more later on. Questions at this point? That's basically all I have before we go into the actual example.
Connor, can you talk a little bit more about how to determine the monthly savings? If it's not just like a divided by 12 sort of situation?
Yeah. So Sammy's also got this in the exactly that. But there are some assessment recommendations, like say you had a chiller unit, an air conditioning unit. Most of the time, you're not going to have savings for that in the winter months. You're not going to have savings from an air conditioning unit because they usually shut down air conditioning in the winter because it's already cold outside and they turn on the heating. So if you had an AR with an air conditioning unit, you've got, you'll have the months where you basically use air conditioning. So like May, June, July, August, and September. So you would have to separate out that by the months that you want it. So May 1, 2, 3, 4, 5. So in this case, you would divide your savings by 5 and put them in the 5 corresponding months. If you're really cool and you want to make sure it's exactly, you can also really hone into it month by month and see exactly how much air conditioning they're using at any specific time. But I think for our purposes, as long as you have them in the correct section, correct month section, like May through September or November, December, January, February, it should be okay. So that's just what I have. Mariah, is there anything you'd like me to talk about a little further?
Can I add something, Connor?
Yeah.
So I would say that if you're in a pinch and you're working with a recommendation that you know is based on heating or cooling, usually that's driven by the outdoor air temperature. So if you're really desperate, what I would recommend you do is normalize by the average monthly temperature. And for example, let's say you're working with an air conditioning unit, I would probably make an assumption that during November through March, it's not on. And then from March through October, it is on. And then I would probably normalize the total energy savings using the average high temperature of the remaining months that we're assuming it does run. And so that should give you a spike that you would expect during the hottest months. You would expect to be saving more electricity during hot months. And conversely, for natural gas, you should expect to save the majority of heating gas during the coldest months. And I would use outdoor air temperatures if you have no other better way to estimate the monthly changes, variation.
Thanks, Michael.
And I think Andrew brings up a good point in the comments. The reason we care about which months you're getting savings in is because these ozone non-attainment zones are impacted heavier in certain months. So like you said, Uinta Basin is wintertime, Wasatch Front is more summertime. Yeah, I don't know if you want to talk about that at all, Connor.
Yeah, I can talk about that. So like Mariah said, so the EPA goes out and they conduct these assessments of these areas, and they give them non-attainment values, but those non-attainment zones are only for a specific set of months. So like the Uinta Basin, they have really high O3 levels during the winter months. So basically, if we can find a way to like cut back on the ozone that's being produced during those winter months, it'll help us get out of that non-attainment zone and get us back to a place where we want to be so that the air is safe and healthy for everybody. The Wasatch Front, they have an ozone zone. They have an ozone season and they have a PM 2.5 season. So during the summer months, they have a hard time with ozone. Our ozone levels spike to unhealthy levels, but then that tapers off when you get to the winter. But I'm sure everyone's noticed in the winter, you'll look out across the valley and see all of this inversion, all of this gunk in our air, and that's PM 2.5. And during the winter months, we have a spike in PM 2.5 across the Wasatch Front. So basically, we have 2 non-attainment zones for ozone and 1 non-attainment zone for PM 2.5. But for our purposes, the ozone and the PM 2.5 modeling domains, they overlap. So that's why you just choose one or the other. Sorry.
I'll just add real quick. All of this is good information for us to know to understand what's going on, but it's also just all calculated in the calculator that we're providing you.
Yeah. So you don't actually have to go out of your way to figure this out. We've already figured it out. You just got to put your stuff in the calculator and it'll spit out the numbers at you. All right. Is there any other questions before we move on to the example?
If not, I'll go ahead and start with the example and share my screen. All right. Can everybody see my screen? Thumbs up. All right, sweet. So we're looking at an example from the TradeStar report. It's the second AR in that report. And the AR is to install energy recovery ventilators. And so I'll just show you, there's a really nice picture here that it kind of explains what this AR is. It's essentially taking old air has to be recycled out of the building and new air brought in to the furnace. And so it's using a heat exchanger to transfer some of the heat from the old air leaving the building and put that into the new air coming into the building. So the savings from this AR come from saving natural gas in the furnace because it doesn't have to heat up air as much. because some of the air is coming in preheated. And then there's also electricity cost to this AR because it costs electricity to run these heat exchangers, the ERVs. So that's a brief introduction of the AR. And down here, it talks about the savings numbers, which we'll come back to. Right here, I have downloaded the user-friendly AR calculator, which is something that all of you can do and will do. Like Connor mentioned before, please don't just edit the one in box. Please download it to your own computer and then edit it on there. So here's the README tab, the very first tab, and we're just going to do this single AR. So we're first going to go to the data insert sheet by selecting the tab below and type the name of the assessment recommendation in the red box. So that's here, and we're just going to use this first red box, the first AR, and we're going to call this install energy recovery ventilators. Okay, so we've named our AR. The next step is going to be to put our savings in the blue boxes. And so this is going to be our gas and electricity savings. And in this case, we're going to have both gas and electricity savings, except the electricity will be negative because it's costing electricity. And another interesting thing, this one's going to be winter savings because the furnace runs in the winter. And so we could use the method that Michael was talking about where we can normalize by the temperature. But for simplicity, just for the example's sake, I'm just going to divide the savings between 4 months, November, December, January, and February. So we're going to start with natural gas. We can see in the AR, the savings are 577 MMBTU. And so we're going to come here and do 577 over 4, since I'm going to just put that into the 4 winter months. Perfect. So we can see the total is the 577, which is what we expected. And then the electricity savings, we can see here, it's going to be an increase. So it's negative 13,494 kilowatt hours. So we're going to come here, negative 13,494 kilowatt hours divided amongst the 4 months. And we'll put that in the other cells. All right. So now we can see that these numbers, the totals, come out to what we expect them to be. That's a good check, just to make sure we've done it right. The next step, if we come back to the README tab, determine what type of burner we have. And so when we went on this assessment, we attempted to get burner information, and we weren't able to get a specific type of burner. So we decided the best one that we're going to use is the general less than 100 MMBTU per hour, which that's a reasonable assumption because we're saving over the course of this AR in a year 500 MMBTU. So that's probably a reasonable assumption. And we, like Connor said, if you have questions about burners, you can talk to anybody in the air quality team or to Dr. Kelly, and we'll consult and be able to give you the best answer for what burner to use. So we finished that step. The next step is to determine the non-attainment zone that our facility is in. And you can click on this link to get a map of the non-attainment zones. And I've got it pulled up here. TradeStar is located in the middle of Salt Lake City. And so that's right in the middle of the Wasatch Front ozone non-attainment modeling domain. So that's the one that we're going to use. And it's worth it to note that if you've got a facility that's like near one of the borders of these non-attainment domains and you're not sure if it's in or out, we do have the exact coordinates of them. And so we would be able to help you with that. You can just ask anybody on the air quality team. So we saw that that's in the Wasatch Front non-attainment domain. the Wasatch Front Zone. So we'll come over here, and this is where all our results are spit out at us. And in the README tab, it says the only place we edit things is in this data insert sheet. And so that's the only place where we're going to input numbers. So we're going to take numbers out of the Wasatch Front Zone. This is giving us our emissions savings. So there are a whole bunch of tables on this page. It's a little overwhelming at first, but we're just going to look at the first three, because these first three tables are, are the ones that have to do with our AR, the energy recovery ventilators. So this first table is a total summary of natural gas and electricity savings combined. Second table is the gas savings only. And the third table is the electricity savings only. And then it's also worth mentioning here to the side, there's just one table that gives you the total savings for the whole assessment. And it's also electricity and natural gas for the whole assessment. And so that would be useful if you input multiple ARs into this spreadsheet. So we can take any one of these tables. For example, if we need the natural gas savings specifically, we can copy this table and use that in our report. As we can see, kind of what we expect, all these negative numbers in the electricity only. And uninteresting to note is these two columns have positive numbers. The reason for that is because these are specific to the non-attainment zone, and that's influenced by the natural gas emissions as well. So that still affects this table. So that's the whole example. Does anybody have any questions about that process? All right. If not, I'll stop my share.